So, hello everybody who are listening this presentation for developers online second edition. And this presentation will be held in English because there was the request to speak in English because there are some English speaking participants listening right now. So let me present to you the way of thinking and the approach to the architecture in the mobile development application. And please help me and go with me while looking for the best state management in Flutter. My name is Rafał Piekara. I'm working as a front-end and mobile tech lead in uPacjenta.pl, this medtech company offering the in-house, in-home blood test and the consultation with doctors for the patients. We are in 20 cities in Poland, and we have also the quite strong technical team, even though we are concentrated on the medical part of the business. So to begin, let you give me a few words about the Flutter. What is Flutter, and why it's so popular right now, and why I think it should be the great game changer in the mobile development in the next years. So Flutter is the mobile development framework released by Google, and it's the new approach of building the UIs on the mobile application. It's a declarative UI application framework, so we can build our UI in a declarative way. It has great performance because instead of the building the web views like the PhoneGap, instead of having the JavaScript bridge like React Native, Flutter has his own drawing engine, and it's building his own controls, his own UI parts in the mobile application, and it's using the great painting engine called Skia. Another strong thing of Flutter is the Dart language. I'm a mobile developer, and I came to the Flutter from first. I began with native languages, with native programming on the mobile platforms like Swift and Java. Then I switched to React Native, which was the breaking point in mobile development, having the single code base and possibility to run the same code on both platforms. And then came Flutter. And what was difficult for me in the React Native, that this is the thing that the React Native is written in JavaScript. We are writing JavaScript or TypeScript, the superset, but anyways, it's JavaScript under the hood. So we can simulate some kind of the strong typing, but in the Flutter, it's evolved in the next level. So the Dart language is the really great power of Flutter. It's the strongly typed objective language which you are using during the building of the UIs. And what's more, like in other frameworks, for example, Android, you are building the UI using XML files. In React Native, you are using CSS in JS, or in general, the CSS engine to style the UI. In Flutter, you are doing everything in Dart. This is very good for the beginners, for the junior developers who are starting his work, who are starting his journey in programming. The developer should know only the one language to start coding in Flutter. So it's for me, it's very good. It's quite an amazing thing that you don't need to have any other tools, any other knowledge spaces to start coding in Flutter. What's more, Flutter has hot reload. Hot reload was first introduced in React Native. It allows you to reflect the code changes on the UI without rebuilding the application. And it was working quite good in React Native, but the Flutter has the hot reload engine really also in the next level. It's very fast, and you can run the Flutter application during the development on multiple devices. You have, for example, 4 iPhones simulators open. You are coding, you are hot reloading, all devices are refreshed with your changes. It's really amazing. It's really fast, and it allows better cooperation between the developer and designers or the product team. And this, last but not least, the most powerful thing about Flutter is that this is the multi-platform solution. So coding in Flutter will deliver the application on mobile, on web, and on desktop. And the general purpose of Flutter is to have single code base and to have applications with ability to run on each platform. Actually, mobile is already released, and web and desktop is just the very first versions, but it's going in the right way, in a good way to allow developers to build multiple applications with one single code base. So I think this is enough about Flutter. So let's speak about the state management in mobile applications. As I written here, there are as many state management approaches as the Flutter developers are currently coding. This is the phrase very known in Flutter community. Because Flutter is the young technology, it has not many conventions yet, many single source of truth, and or many generally agreed approaches or best practices that each developer can go with the state management on its own way. What is the state management in the application, in the mobile application, or I would rather say in the client application, because the same thing is in the UI of the web applications. Each UI is data-driven. Each UI should represent the data. This data should come from the other data sources to the UI. UI should fire some events to change the data, and this UI should also reflect those changes. Having the UI of a mobile application, we have many of the components, and the data should be shared between many of UI components because we have multiple screens, for example, and requesting to the API each time you are entering the screen or you are switching the screens will cost your performance, for example, money for the servers and so on. Those changes in data, while changing something on the screens or in the general state, should reflect on the UI in the synchronous way. User shouldn't experience any lags or waitings while changing the data. So the having shared state in application significantly improves the user experience. When the data came to the application once, and it can be shared between multiple components. From my experience and my perspective, having the good state management approach in the beginning of the development of the mobile application will significantly change your experience as a developer, will significantly give the value to the business, will significantly reduce the amount of errors and the frustration during the development. So having the Flutter, we need to know the word widget. In Flutter, everything is in widgets. We have button is a widget, the screen is a widget, the page is a widget, the form is a widget, everything is the widget. And widgets can have two variants. First is a stateless widget. Stateless widget presents the content, has static content. Data for this widget, so data presented by this widget, can be hard-coded or passed by the parameter. Stateless widget has no internal state. So for example, having the form as a stateless widget, we cannot modify the state of this form. Let's see on the code example. This is the example of very simple stateless widget. I called it header. It's just the text with some text and some styling. and it can be embedded anyway anywhere in the application. So this stateless widget can be fed by the data came from the other widget, for example, from the parent widget, and it can have the header text property, and this property could be passed during constructing the widget. So it can be something like this. The text widget is having the header text property. This header text property is the data for this widget, and it is passed, like you see in the below the screen, as a parameter in the UI declaration. Another thing is our stateful widgets. Stateful widgets presents dynamic content. So the content which can change during using this widget, which can change in effect of the interactions of the users of the application. Data to this widget can be passed as a parameter, but also stateless widget can have his own methods, his own data sources inside the widgets. So we can have, for example, API request fired from the interior of the widgets, from the public methods, from the private methods. And also, data can be modified from inside the widget. Like you have some interactions on the form which can be validated. You are seeing the errors when typing, for example, email without the @ sign. That's why the state of the widget changed and it displayed the error on the form. This is the simple example of the stateful widget. It has the state of the header text. It's a property of this widget. And this property is being changed in the change header function. This change header function is run by the raised button. And then once clicking on this button, the text is being updated with the header text property. So summarizing the stateless and stateful widgets in few words. First of all, it's a common building block in the Flutter. So when you are starting any tutorial, any beginner crash course with Flutter, you will know about the stateless and stateful widgets. You will know how to build the stateful widgets, which are working great with hot reload. And you will know how to pass the data to the stateless widget, how to feed the data in the stateless widgets, and how to pass the events changing the state and how to update the state. So in this, in both of those widgets, state is managed on the widget level. There are no other source of state. There are no other source of data. Those widgets has data inside. State is not shared. In this way, in this relation, state can be only shared in relation parent to child and back. We cannot share the state between the parents, between those widgets on the same level. We can have another request. We can have another data feeds in other stateful widgets, but it will come with redundation, with duplicated request, with duplicated state. And we came with that the try purpose, that try principle is broken in our application. The solution for that is the app managed state. App managed state means that we can lift up our state to the, let's say, master component, master widget, and pass our state, pass our data down to the child widgets. What we have here, we have the solution for redundant code and duplication with stateful widgets. We have the single source of truth. We have one single point where we can manage our state, and the state is passed as the parameters inside the widgets. If there are some people listening from the React world, it will come with the some well-known problem from the React community called prop drilling. I will say about it further. So this is the example of the app managed state. We have some kind of the widget which encapsulates all other widgets in our application, and it has the state, the simple state in this example, with some labels and text. And we can have the callback, the function which will update label and header, and it can be passed into the child widget. So we have two child widgets here with some properties passed from the app managed state from the master widget down to the tree. And here is how header looks like. It's like the stateless example of from the previous example with stateless widgets. It's header text property passed in the constructor. Having the second widget, we can see that we have here the property, string property label text, and we have the function parameter. This function parameter is the callback passed from the master widget, from the master widget down to the label with button widget, and it allows to attach to onPressed event on the raised button, which will update the text widget from this widget, but it will update it via the callback from the app managed state widget from the main widget up in the tree. So let's summarize a few words about app managed state. What we have here, we have the single source of truth. We have one place to manage the state. That's good. We can somehow test it. It's easier to test it somehow. But what's more, it can lead us to have the God class, to have the thousands of lines class with the state changes, with callbacks, with validations of the state. Second thing, it can lead us to the props drilling. Imagine that you have the tree of widgets, which has widgets as a children, which has widgets as a children, and widgets as a children. You should pass the prop from the main widget down to the tree and pass it, and use other children only to pass the property down to the tree. It will be very, very hard to debug when you will come with some errors. The advantage of this is that you have the mostly stateless widgets. You don't need to take care on changes of the state inside the widgets. The third thing which will come here is a callback hell. As I mentioned in the props drilling topic, you can have the widgets inside another widgets inside another widgets, and you should have callbacks which should be passed down to the tree, and you should have callbacks running callbacks and so on. It is called callback hell. So it will cause the really unmaintainable architecture. So app managed state is good to use in not so complex applications and not so complex solutions of the logic. Fortunately, Flutter has a great community. The community of Flutter developers came up with some best practices and packages which you can use in your application, and they will help you to manage the state in the right way. Those packages came from the business needs. So the real business, real needs of the clients caused the building of those packages and those approaches to manage the state of the mobile applications. Some of them are well known from other frameworks, from the web frameworks, but some of them are very specific and quite innovative for the Flutter community. First of them is Mobx. Mobx is well known in React. When I was starting my first React Native project, I was written in Mobx, and I liked it a lot. It's based on the reactive principles on Eric's Dart. It encapsulates many of the best practices. Has great community proof, for example, for the React environment. And it also came from the business needs because it's based on the observer design pattern. I would like to explain it like this, that the business would like to observe some data and would like to observe the changes in this data. For example, charts, for example, dashboards. And any change will reflect when the business is looking on this data. The data in Mobx is reactive. So we are checking the reactions fired by the data change. It is great described when thinking about the Mobx building blocks. What are the Mobx building blocks? First is the observable. In simple words, observable is any data that can be changed. For example, we have the invoice. Invoice is composed of the products and the prices and the taxes. And the taxes can be changed while you are adding some products. The total amount of the invoice can change when you are adding more products. So this data can change. In this example, the price of the total invoice can be the observable. We have actions. Actions is an event that triggers the change in the value of the data we called observable. Action can be any user interaction. Action can be fired by the system. Action can be fired by the API requests. Actions also can be fired by the push notifications. And when we have action, we have also reaction. So reaction is the change in the application state and reflection in the UI when the data, when the observable has been changed. So action is changing the observable, and then observable firing the reaction. Let's see the example. In this example, we will be using another building block. This building block is called observer. So if you want to read the data from the Mobx store, from the Mobx managed state, you should wrap your widgets in the observer widget. This observer widget has the property called builder, and builder is the function which will build our tree of widgets inside this observer and with access to the Mobx store state. So in few words, observer is observing the observable. It's quite obvious, but here it's working very good when in small and not so complex applications. When the user fires the action, observable is being changed, and then the reaction updates the change on the UI. There is one disadvantage, one minus of the Mobx, according to me. In the pure Dart Mobx library, it's a bit of boilerplate. You need to type a lot. You need to type in the way that it's not quite easily readable, like on the left side. You need to wrap all values in observables. You have no such power to control the types of the properties in the store. In order to avoid that, and in order to use the decorators like add observable or add action, like it is presented on the right side of the screen, we need to use additional libraries like build runner and Mobx CodeGen to generate some additional classes in our code. It will reflect with changes in the code. It will reflect during the code review, and it will reflect in the developer's mind, which we should remember about the generating the code for the store. Here we have the comparison, how it looks like when using pure Mobx and how it looks like when using generated code with the decorators. So in the pure Mobx, we need to call the actions with the call function invoked. We need to call the value of the property in the store. In generated code, we have direct access to the properties of the classes. It's easier to understand and easier to read. So wrapping the Mobx. Mobx has good and tested Rx pattern. For Rx fans, it's a very good approach to use this library to build the reactive application. It has decorators. Decorators allows us to easier declare the observables and actions. To use them, we need additional dependency. We need additional boilerplate, and we need to remember to decorate our properties in the class. So for example, we can have class with many properties which are not decorated. It can lead us to some misunderstanding of the logic of our application. We need to decorate any property we want to observe. But anyways, the Mobx is elegant and useful solution, but good, according to me, good for not complex logic. The next solution also came from the web development is business logic component called Bloc. What is Bloc? Bloc stands for the business logic component. It gives us the single responsibility principle of our application, and it can give us the event-driven architecture. What are the building blocks of the block? First is the stream. Stream can have any data change which is published to the stream. We have events publishing the change. Any data change is publishing the event, is firing the event. So events are fired during the interaction of the users. And then we need to map our events to the state changes. We need to remember about it and have this well implemented in the Flutter application. This is the simple implementation of Bloc without any other library. We have the controllers, the stream controllers. We need to remember about streaming any value, any data, and we need to have the listener to the stream and to changes to our events. Then we have also mapping events to the state. It's a great challenge for the developers to code it correctly and in a clean way, and not to destroy the readability of the classes. Also having the controllers, the stream controllers, we need to remember to dispose them to avoid memory leaks in our application. But the great advantage, according to me, in Bloc pattern are events. Events are really good when you want to monitor what happened in your application. Events can have also the possibility to store its data. So having events in your application, you can reflect any change and you can go back to any change in the history when you have the list of events. Here, it's the simple implementation of the Dart package of the Bloc. So external library. It's a simple state of user profile using equitable library to have a better experience by comparing objects and less code boilerplate. So we have some changes in the state, and only the profile loaded state has some data. So this change, like profile loading or empty profile, will not have any data which we can use to update our store. We need to map our events. This library has a less boilerplate like comparing the events. So we just yielding the events. We are just firing the events according to the changes in the application. We are changing the state according to them. In order to use the state data, the block data in our widget tree, and reflect it to the UI, we have the BlocListener and BlocBuilder widgets, which should wrap the widgets with the access to the block data. I think widgets in block pattern are really, really amazing. So in the map state to event functions, we can just compare if the event is kind of specific class and then proceed it by hard coding or coding the method, the handler inside the event, like here. But what about here? Having the handler inside the event, we don't need to take care on comparison. And also having the event handler classes. We have exactly the same way, but we have the architecture much easier to test, which is very important in mobile development. So, wrapping up the blog, we have to work with streams. It can be uncomfortable for some of developers. I've read a bit on Stack Overflow, on the Flutter groups, on Facebook, and there are many complaints that the stream is not the comfortable way of work for some of the developers. So it's good to know that. It generates for us a lot of boilerplate, but it's easier to test. We need to take care about events, about controllers, streams, and so on. But having this separated, we can test it very easy, and events are very explicit while reading the already created application. The next pattern, I think the most famous pattern in the React world is Redux. Redux is based on dispatching actions, so very similar to Bloc where we have events. Redux has actions like acting exactly in the same way as events in the Bloc. And Redux has another two principles. He has pure functions and a single store. The store is single source of truth. And those other two building blocks like actions and reducers gives us the control on the data change. So action is the object with a specific type and the object which holds the data needed to change the state. Reducer handles the logic, handles the way how the state is changing depending on the action type. This is the example of the Redux actions in Flutter or in Dart. In general way, we have classes. So each class is the type of the action, and those classes has payload property. Its payload property is the property, it's the data needed to change the store and the state of the application. We have the reducer with the logic. So we can have the switch where according to the action, we change our state and we feed our state with the action payload, the data added to the action. The dispatching of the action is very easy in the widgets. So we just need to use the provided store provider object class, which can give us the app state declared in the beginning of the application. And there just dispatch the action, means the class with the specific type, passing the correct payload to this. What we have in Redux, I think it's difficult to understand for the beginners. For the junior developers, which are not quite understand the flux pattern used in Redux, the dispatching, what's going on with dispatch actions, what's going on with those reducers. It's not quite clear vocabulary here. We have the boilerplate. We can have multiple different objects like actions, like classes, like reducers, like state. It can be confusing in the beginning and then can lead to the many of the unmaintainable code. But it's easy for web devs. When you are going to the Flutter from the web development, you will understand the Redux in Flutter on the fly, and you will start coding it just in 15 minutes. Last but not least, and according to me, the most powerful tool created by the Flutter community for the state management here, it's called just simply Provider. Why I endorse as much Provider? Because it's so powerful. It has multiple ways of usage. It can be used as dependency injection container, and it can be implemented in different layers of our application. Let's see the building blocks of the provider. The first, the most powerful building block is the provider. So it's just a container for our states, means the classes written in Dart. Then we have the consumer. Consumer is the widget, which is reading the state from the provider. And then we have change notifier. Change notifier is the element, the class which is the parent of the any state classes. And change notifier give us the interface to notify all listeners and consumers about this change in the data. Another great tool with provider, it's easy way to implement multiple stores, like multiple state classes. Like here, it's the very simple example, but here we are injecting the to-do list, which is a state actually, and we are injecting the file-based auth service, which is the service. So it's like the dependency injection pattern here. So the MultiProvider is a really easy way to provide to the application multiple dependencies, which we can use further in the widget tree. Here is the example just of the change notifier. This change notifier gives us this notify listeners in our classes. What's about provider? It has very easy implementation. We have just provider package and nothing more. We have no boilerplate. In the basic implementation, we don't have any streams or other strange looking things like reducers or observers or observables. We have just pure classes with some mixing of change notifier, and we have the provider in the widget tree, and that's it. It's very easy. Also, we can, of course, we can combine it with the streams, but it depends really on the logic of the application. What's more, we have the multi-layers. We can provide our dependencies to any layer in the application. We can have global providers and less important, less smaller providers in the children of the widget tree. And as I mentioned, what is according to me the most powerful feature of the provider, it couldn't be used only for the state management, but also for the dependencies, like services, like any feeds in our application. So we have the minimum of the setup and the variety of the power here in the provider. So we came up with some summary of the most used, most famous Flutter management tools for Flutter management libraries. And then let's go through the short case study here of the application I had the chance to develop. And this is just a hypothetical way of work, but I want to show you some kind of examples of using each of those patterns here. So we have the company social application. The company decided to build the application with the user profiles list. So we have the feature where we can have all my coworkers, and I can filter just the list of the coworker and check its profile. Then I have the chat. I can look for my coworker and start the conversation with him. And then I have the social wall, like on the Facebook or any other social media application with the groups, discussion groups, posts, comments, and reactions like likes or endorsement here. So the first feature, we have user login. Our goal is to log users to the application and display the user profile screen. What we can use, it's the first iteration, so let's use the stateless widget for the displaying just the profile, and the stateful widget with the login action and API request. It's all that. We logged, we received the user from the response, and we are passing it to the user profile stateless widget as a property. So the feature done. And next, we have the users list. So it could be kind of difficult way because we have our user profile and we have the user list, and we want not to show our profile in this user list. So we want to somehow know about the ID or about the structure of my profile object. So I can lift my state up to the app state pattern and pass the prop down to the profile list or to the user profile when logged to the application. So we can just use some callbacks from the login form. Okay, it's implemented, it's working, feature done. Okay, thank you. Next, we have the conversations. Conversations module. On this conversations module, we have the goal to have the conversation screen with the also list of profiles, and we can have the chat screen. So here it's another layer in the application. So we are trying to implement it with the app state. It's quite coming with the props drilling and some too much callbacks. Okay, it's hard to test. So we go through the well-known solutions. So let's go through the Redux or Mobx. I will leave here the equal sign because all those solutions are mature, are great, and are well tested by the community. So let's, for example, have the Redux because I'm from the React world, so I will go with Redux. I'm getting rid of stateful widgets. I have all stateless, all action driven. I created some actions like start the conversation action, like send message action. All this working great. So the feature is implemented. And then I have the social wall. Social wall will have some complex logic. So in writing posts or comments, I can mention my coworkers, my members. I have comment the post. I can create, edit, or delete the post. I can endorse the comment. I can endorse the post. I can join the group of the conversation. So it's it can generate much more code for the Redux, for example, or it can be difficult for me to implement it in Mobx. So I will go with Bloc or Provider, and using Provider as the dependency injection or Bloc as the event management system. Here I can easily update my state and have my own logic moved to the Bloc module, so the business logic component modules in the application. So I'm just firing the events and updating the state. The feature is done. So having this quite short overview on the real case of the application, let's define the best approach. So according to me and my experience, as I'm the mobile and front-end developer working over the years in the great big companies, in the startups, and building the enterprise products and also the startup products, I have some thoughts in my mind and some experiences allowing me to compose this kind of phrase that the best Flutterstate management approach is the combination of business logic and developer itself. So what's about business requirements? Business requirements are the main driver when building the application. Even you are building the application for your own, you have some business, means some purpose of the application. It should do something. So the first goal of the developer building the app is to fulfill the requirements. You have the requirement to have the filtered list. So first you need to build the filtered list and you need to give this requirement to be fulfilled. Next is the logical complexity. Even easy to understand business requirements can have very complex logic. Sending the invoice is a very easy business requirement, but the logic is very complex. We have taxes, we have a way of sending, we have way of calculating the total amount, we have pro formas, and so on and so on. And here, wrong choice in state management approach will change the app in difficult to develop and maintain Frankenstein monster even. And the last thing is the developer. Yes, it's you. Developer is important in the whole development of the application. We'll need to consider the developer's skills and personal preferences. There are many solutions in the market, many repositories with the great code examples, but one developer can feel comfortable with this solution and can feel uncomfortable with the other one. So working on the best on the app should be the pleasure also for the developers and should respect his preferences here. So wrapping up, the best Flutter state management approach is the combination of business. It should fulfill the requirements. It's the logic. It should respect the logic. It should be adjusted to the logic of the application. And it should take into consideration the developer skills and preferences in the team. What is my choice? I would go with Provider. Why? It's simple and the most powerful. But it's my personal choice. It's my point 3 from my best Flutter state management approach. So thank you for spending this time with me and pacing amongst those solutions while looking for the best state management in Flutter. Don't hesitate to contact me. I'm the front-end and mobile tech lead developer in upacjenta.pl. Also, I'm working on the great community project called Achieve Guru. You can have the link in the PPT, and you are invited to join the group. Also, I'm a blogger. That blog is in Polish, but don't worry, I will consider to change it to English. So my blog is on the grubykodzik.pl. So if you have any questions, don't hesitate to contact me. So my name is Rafał Piekara, and thank you very much. And I'm passing my voice.